Hey everyone, we're going to get started on questions 5 and 6 on the Statistics Chapter 5 practice test. So what we have here is, in a particular game, a fair die is tossed. And if the number of spots showing is either 4 or 5, you will win $1. If the number of spots is a 6, then you win $4. And if the number of spots showing is a 1, 2, or 3, you win nothing. And you're going to play the game twice. So the first part here is, what's the probability that you win $4 both times? So for question 5, that's the same thing as saying, what's the probability that the first roll is a 6 and the second roll is a 6? Now, the first roll does not affect the second roll. So in effect, we're saying that the two rolls are independent. And if the two rolls are independent, that means that in order to figure out the AND probability, we can just multiply the two probabilities together. So the probability of A and B is equal to the probability of A multiplied by the probability of B. Likewise, the probability that the first roll is a 6 and the second roll is a 6 is the probability that the first roll is a 6 multiplied by the probability that the second roll is a 6. Considering we're dealing with a die, both of those probabilities are going to be 1/6. 1/6 multiplied by 1/6 is, of course, equal to 1 over 36. So there's a 1 out of 36 chance that you're going to win a $4 both times. For question 6, we need to look at this. Well, let's read it. The probability that you win at least $1 after 2 games is, and the phrase I'm going to highlight here is at least $1. Because whenever you see at least, we're probably going to use properties of complements in order to compute that. So what is the complement of at least $1? Well, the complement of at least $1, that's winning nothing. Because if you won at least $1, or either you win at least $1 or you win nothing. There is no two ways about it. One or the other is true. So if using properties of complements, then the probability of winning at least $1 would be 1 minus the probability of winning nothing. So now we can just concentrate on what's the probability of winning nothing. The probability of winning nothing is the same thing as saying you roll a 1, 2, or 3 in the first roll, and you roll a 1, 2, or 3 in the second roll. And just like last time, the two rolls are independent. Anytime you're rolling dice, the two rolls, or however many rolls you have, is going to be independent. So the probability of A and B is the same thing as the probability of A multiplied by the probability of B. Or in our case, the probability of rolling a 1, 2, 3 on the first roll and a probability of a 1, 2, or 3 in the second roll is the same thing as the probability of a 1, 2, and 3 in the first roll multiplied by the probability of 1, 2, and 3 on the second roll. So how many outcomes are favorable to rolling a 1, 2, or a 3? Well, that's just the 3 outcomes. 1, 2, or 3. So 3 outcomes out of the 6 outcomes that exist on the dice. And then same thing here. How many outcomes correspond to a 1, 2, and 3? That's 3 out of the 6 outcomes. Multiplying all that together, you get 1/4. And so what we're saying is the probability of winning $0 is equal to 1/4. Well, that's great, because now we can answer our question. If you will remember, our question is, what's the probability of winning at least $1? And we found out the probability of winning at least $1 is the same thing as 1 minus the probability of winning nothing, no dollars. course, we now have a number for the probability of winning no money at all. It's 1/4. So there's a 75% chance, or the probability is 0.75, that you're going to win at least $1 after 2 games. So that wraps it up with questions 5 and 6. We'll see you next time when we continue our look at your Chapter 5 practice test.